Okay, let's continue looking at lesson 3.3. This time, let's look at an application problem. We left off graphing. I showed you Desmos to kind of help you graph points. And so now here's a situation where we have, again, it's a very simple scenario. We're planning to sell t-shirts. We have a setup cost and then how much they charge, the company will charge us per shirt, and then how much we plan to sell. So you can see the table of values here in terms of the cost where I created, and then the sales, and then the profit. And it's important to remember for profit, right? It's the sales minus the cost. And so then you see we end up with these values. And so since you see this constant rate of change, these constant values change, these values are changing, these output values are changing at the same rate with linear equations, which allows us then to solve questions by finding slopes. And in this case, how much profit does the team make for each shirt they sell? So I'm looking at the profit here. I find the slope in between two of the values, and you can see you make $90 per 10 shirts or $9 per one shirt. So you're at that slope or the profit would be $9 per shirt. Now, if I was going to create equations for these, here's the one for cost, your starting value, and you can see this was increasing $6 each time. That's what our cost was. And then you can see for sales, it's just $15 per shirt, where X is the number of shirts. I guess I could use T here, but I'm using X instead of T here. And then profit is 15X minus 75 plus 6X. And then when you simplify, you get an equation for profit. Once again, notice on the top when I use T, number of T's there, so I'm using X to represent that. And so with this, how much money will they raise to sell? If they sell 30 shirts, you just substitute 30 into the profit equation as what's going on here. And then answer these questions. How many shirts will they have to sell to avoid losing money? That means you want to set the profit equal to 0. Set this equation equal to 0 and solve. And so then you can see they need at least 9 shirts. It's 8.33, but you can't sell 8.33 shirts. And then similarly, how many shirts do they sell to make a profit of 500? Notice I'm setting the profit equation equal to 500 and solving for X. And so they need to sell 64 shirts. So take a look at that, or pause to look at the math with that there. Okay, moving on to another scenario of the Daily Latte. So very similar, again, situation in terms of you load your card with $50, and then each day you spend $263, and so you can kind of go ahead and answer these questions here. But more important, after your estimate here, is actually the creation of the formula. And so as you look at that formula, B is equal to 50 minus 263T, where B, again, what does B stand for? B stands for your balance, and then T is for the number of T is going to be for the number of the days that you're for each weekday, right? How many? Because you lose 263 per day when you buy your lattes. And again, you can go ahead and calculate and see how my little calculation here. And so notice it will last 19 days in order to, if you put $50 onto the balance of that card. So you can look at that. And then you have problem situation 3, again, looking at rate of change, slope of line. You see 4 different values. Notice that the flat line would have a slope of 0. You can see these numbers here. You can see Jamie is decreasing. That's why I know it's going to be negative. Jonas is increasing. And notice I drew the slope triangles in there so you could see them. Over 3, down, and then down 10. Notice it depends on the values here. And that's where these slopes come from. And then, again, noticing the direction of those lines tells you if the rate of change are positive, negative, or 0, meaning that our values decreasing or are they increasing per week. To continue, then, once we have the equations, because we're going to use these slopes, we have these initial values from the y-intercepts. We can go ahead and answer questions like this, especially for Jamie is at 185, and she's losing weight 5 pounds every 4 weeks. And so then that comes out to an equation like that. 125 comes from right here for Jamie. That $1 means, 1 pound, 1.25 pounds. And then you can go ahead and answer those questions. And so looking at that, we have the answer to that. Notice we set 173 equal to your weight, and then you solve for t again, the number of weeks. We also had another way to kind of look at this, especially if the graphs, when the graphs are clear, we can read them. What we did works perfectly, right? We can read the numbers and calculate slopes. Now, if the graphs are not as clear, something like this, then, or the points are a little bit more difficult to calculate, then we're going to use the formula for a slope, y2 minus y1 over x2 minus x1, or the change of the output or the change in the input, as you can see that. And once you have that in this situation, you can see where we get this value, and you can go ahead and calculate that. Again, this is the general formula for it, and here is how you would use it. When we're moving kind of without the context, we can go ahead and just substitute into that equation there. I'll leave that there, and then I'll leave problem situation 4 up here so you can at least have access to the answers to those questions there. It's a longer problem to explain, but this is what you would end up looking like. And that's it. This one here is optional. It's a little bit more complicated question. I'll show that real quick so you have the answer there. You can pause, but in general, again, we're talking about constant rates of change, slopes, linear equations, and so forth.